Hi, this is Sanjaya Kamat, and today I am going to show you how to find out the Nernst equation. So to find out the Nernst equation, first of all we have to find out the two thing that is nothing but Nernst equation for the oxidation potential, and the second thing we have to find out the Nernst equation for the reduction potential. Oxidation and reduction means two thing is important. And then third thing what I will do here is in third thing I will add both of these, and then final I will get the final equation. That will be my the Nernst equation. That will be my final equation to find out the Nernst equation for the any type of cell, means electro EMF of a cell. EMF is denoted by capital E, and EMF is equal to E naught right minus E naught right plus E naught cell. Okay, in this way. Okay, so E oxidation plus E reduction. Okay, so in this way. So finally, step by step I am going to show you how to determine the Nernst equation. So let's begin. Okay, so for this I have prepared in this paper one by one I am going to show you and explain also how to determine. Okay, this is my so I'm going to show you. Okay, see here, as you can see here, so Nernst equation, see, okay, this, okay, see here. Okay, fan is on, so I have to keep calculator on this paper so that paper will not move. Okay, so see here, so Nernst equation procedure. What is procedure here? Procedure to determine the Nernst equation procedure is what? First step I have to consider general redox reaction. Okay, this is a general redox reaction I will show you when solving this problem. Okay, so in the second step, so what I have to find out is I have to find out the Nernst equation for the oxidation potential, and then third thing what I have to find out is Nernst equation for the potential reduction also, and third and fourth thing finally I will get in fourth step I will get Nernst equation for the EMF of the given cell. Okay, so how I get this Nernst equation for the EMF of a cell? By adding this reduction and oxidation equation. Okay, so by adding this oxidation and reduction, how I will get this equation? How will I will get this equation and this equation? So these things I am going to show you. Okay, so let's see. So below, as you can see below here, let's say general redox reaction in any electrode is this: m power n plus n into E minus. E minus is nothing but number of the electron. Okay, m power n plus is reactant. Okay, and this is nothing but product. Okay, let's say m power n plus is reactant, and simply capital M is product. Okay, so let's say this is equation 1. Okay, after now don't say what is this reaction also. Okay, so say now let it be reaction, let it be equation 1. So now one scientist is saying that according to that scientist, according to Von Hope reaction isotherm theorem, we know delta G is equal to delta G naught plus RT log product by reactant. Okay, so this is Von Hope's is scientist. Okay, and according to Von Hope scientist, delta G is equal to delta G naught plus RT log into product by reactant. Product is this, okay, m, and reactant is the m power n plus. Okay, so this we know. Now come below. Okay, what come below? This let it be equation 2. Okay, equation 2, but we know this is equation 2, but what is delta G, what is delta G naught, we don't know. So where R is universal gas constant, whose value is how much? Whose value is 8.314 joule per mole per Kelvin. Now don't ask me what is this mole. This is SI unit. Okay, joule per mole per Kelvin. we have to calculate. This is constant value, okay, constant value of R. Universal gas constant value is this much. Okay, now T is absolute temperature. T is absolute temperature in Kelvin. Okay, temperature always calculated in Kelvin. Okay, Kelvin. Okay, so this is okay some constant value and some temperature value. Okay, now if I come to the next page, then okay, first of all I am going to keep calculator on this paper so that paper will not move, and then I will further continue. Okay, so no, second thing what is the next process is for any reversible reaction. See, if the symbol like this, okay, if the symbol like this is reversible reaction. If anywhere if you see like this forward and backward sign, then think that is a reversible reaction. Okay, in any reaction, if this sign is given, then we have to know that this is reversible. Okay, so that reaction is reversible. Okay, so after knowing this, see, now I will find out the delta G separately for delta G for delta G naught. Okay, delta G is how much? Delta G is minus NEF. Okay, let it be equation 3. But okay, equation 3 where delta G is change in free energy. Okay, delta G is change in free energy, and delta G naught is what? Delta G naught is minus NEF E naught. Okay, equation 4. Let it be equation 4. Okay, after knowing this, I'm coming below again, where I have to name these all things. Okay, what is N, what is E, what is F. So below what is N then? N is nothing but, we know delta G naught is equal to minus N E naught F. But what is N there? What is E naught there? What is F there then? So but delta G naught is a standard change in free energy. So similarly, N is what? N, small n is number of electron. Okay, so capital E is my electrode potential. Okay, so in the similar way, if you see in this equation 4, delta E naught is my standard electrode potential. Okay, standard electrode potential, and then similarly capital F is my Faraday's constant. Faraday's is the scientist. Okay, scientist name is this, and who gave the F value, and whose value is 96,500 column. Okay, F value is Faraday's constant value is 96,500 column. Okay, so this is constant value, so this value is 96,500. Okay, whose value? Okay, now come below again. Okay, so on substituting equation 3 and 4 in equation 2. Okay, so now what I'm going to do is I'm going to substitute equation 3 value and equation 4 value in equation 2, in above equation 2. Okay, so what is my above equation 2 is then? Above equation 2 is delta G is equal to delta G naught plus RT log product by reactant. So in the place of delta G naught value is how much? Delta G is given to me minus NEF. So simply I substitute those value here, and similarly I substitute those value here, delta G naught value here, and then plus RT as it is given in equation, I will keep as it is. Okay, so into log into product by reactant. Okay, this is my product and this is my reactant. Okay, so on dividing both these sides by, now I have this equation. That's previous equation 2 converted into this reaction. Okay, this equation. Now what I'm going to do is I'm going to divide both these sides by minus NF. Then what I will get finally? E. If I will divide it by minus NF, then NF will be cancelled on both the sides. Okay, on both the sides, so what will cancel? minus NF. Okay, NF will cancel on both these sides. So here what is going to cancel? Minus NF. So after cancelling NF, what is left then? Capital E is equal to E naught minus RT by NF into log into product by reactant. This will be my equation 5. Okay, so this is my equation 5. Now what I am going to do is I will do for separately. Okay, I will find out the Nernst equation for oxidation also, and I will find out the oxidation reaction Nernst equation for the reduction potential also. Okay, so see here, as you can see here, I have find out the Nernst equation for the oxidation potential separately, and then I have find out the another also. Okay, in next page I find out the here also. So one by one I am explaining this way, that I will explain later. Okay, so now Nernst equation for oxidation potential. Nernst equation for oxidation potential is this much. Okay, since previously I consider redox reaction, general redox reaction, so I took separately general redox reaction. Okay, M gives me M plus reactant is divided into product plus electron. Okay, here. Okay, as you can see here, reactant M, capital M is reactant, and it is reactant is converted into what? Product plus electron. Okay, it is separated, that reactant is separated here, and then it rises up, then product is came right hand side. Okay, product is what here? Product is M power N plus N minus electron. Okay, so this is my oxidation potential. In oxidation potential, what happen is reactant will become left hand side, and then product will goes in left hand side. Okay, so this is a reactant, simply reactant. Okay, and this is product. Okay, in right hand side. Okay, so and okay, but in reduction potential, in reduction potential, what happen is just opposite of oxidation potential. Product will go right hand side, product will go left hand side, and then reactant will come in right hand side. Okay, so from equation, so I am continuing. Okay, from equation 5 I am taking again equation 5, and I am again continuing. Okay, so E is equal to in equation 5 is what? Equation 5 is E is equal to E naught oxidation minus RT by NF into log M power N plus by M, simply M. That is above equation is oxidation. Okay, this is my product. Okay, upper numerator value is my product, and then below capital M value is my reactant. Okay, so okay, as concentration of the metal. Okay, M is equal to for any metal concentration, M value is equal to, for any metal when consider concentration M value is equal to 1. So is equal to, if when M is equal to 1, then M value will be 1 in above equation also. So keeping M is equal to 1 value, product reactant value is equal to 1, this then above equation will becomes like this. Okay, is equal to E naught oxidation minus RT by NF into log M power N plus oxidation. Okay, so this is my next equation. Okay, similarly we can find out the, okay, so see, since constant value from above see how this 2.303 came. So question we can write see, I am going to show you how I have wrote this much. Okay, 2.303. Okay, so in calculator what we are going to do is, see, RT we can do what we have constant value F is equal to 96,000. Okay, 96,000, R is equal to, okay, so we can write down the that value here. Okay, if we divide 96,500, okay, 96,500 by, okay, 25, okay, then 2.2.30 303, okay, as you can see here, okay, this much will come, okay, 2.303, okay, okay. So in this way this will come, okay. Then so knowing this value, after knowing this value we can write this also, because m value we know. So in the place of m, because reactant value we know, we can keep in the place of reactant value m is equal to 1. So substituting that value we got this value, okay, is equal to inert oxidation minus 2.303 into RT by NF into log this is reaction equation, okay. So this log is constant everywhere, okay. So log into product, this is product, m power n plus is product oxidation, okay. Because why in base oxidation, here you can see why I kept here oxidation, because I am doing separately for oxidation potential, as you can see here in of oxidation potential. So what I am going to do is, so in my base oxidation, so this will be my equation 7, okay, this will be my equation 6, okay. So on substituting the value of R, F and T at 25 degrees Celsius we get, okay, see, after 25 degrees Celsius it will convert into 273, okay, 1 Kelvin is 273, okay. So 20 degrees Celsius 273 plus 273 plus how much? 25 is given. 273 plus 23 is how much? Okay, 273 is how much? 296 bar, okay. So in this way this above equation also converted into this, okay, 0.0591 by n, okay. Keeping this value, R value we know 96,500, F value we know 96,500, R value we know, okay. Then by knowing this value and in this value R value and F value and T value, since I have given, okay, so I can easily use this value in calculator, and finally we can get Nernst equation for the oxidation potential will be is this much, okay. E is equal to inert oxidation minus 0.0591 by n into log m power n plus oxidation. This will be my equation 6, okay. After knowing this, so I am going to find out the Nernst equation for the reduction potential, okay. Nernst equation for the reduction potential, okay. See, this will be my equation 6. So again I will take the general redox reaction, and then after taking that general redox reaction, what I am going to do is I am going to find out the Nernst equation for the reduction potential also. So m power n plus n e minus gives, when it reacts with both, when this negative electron react with reactant, then it will change into product, okay. Product, simply capital M is product, okay. So in this Nernst equation for the in reduction potential, product will come in right hand side, and then reactant will move to the left hand side. So from equation 5 is equal to inert reduction minus, again I am taking equation 5. So to find out the Nernst equation for the oxidation potential also, and to find out the Nernst equation for the reduction potential also, I will take in both of these I will take equation 5 only, to find out the electrode potential for the oxidation and electrode potential for the reduction potential. I have to take equation 5 only, okay. So we can take equation 5, then we can continue further, okay, to find out the EMF of the cell, okay. So here E is equal to inert reduction minus RT by NF, okay. So equation 5 is this, okay, RT by NF into log m by M is what here? M is product, just opposite of oxidation potential. Okay, oxidation potential, in oxidation potential, what capital M was reactant, but here what is here? What is capital M is product. Okay, just opposite. But here, but I am doing for reduction potential. M power n plus is reduction. Okay, so it is reducing, so it is reduction. Okay, so electron is going to be loss here. Okay, electrode potential is losing here. Okay, losing his electron. Okay, so E is equal to inert reduction minus 2.30 into RT by NF log into product by reactant. Okay, so as concentration, again here concentration is M is equal to, but in this reduction potential just opposite of oxidation potential. Why? Because here product is becoming 1. Okay, but in oxidation potential the reactant is becoming 1. Okay, so just opposite of that. Okay, in oxidation potential reactant is equal to 1, but in reduction potential product is equal to 1. So I am going to substitute this value in this equation, in previous equation. Okay, so E is equal to by keeping this value M is equal to 1, my equation is becoming like this. Okay, E is equal to inert reduction minus 2.30 into RT by NF into log 1 by M power n plus reduction. Okay, reduction, because I am doing for reduction potential. Okay, and this is my reactant. Okay, so after knowing this, we know E is equal to inert reduction plus 2.300 into RT by NF into log M power n plus reduction. Okay, so this value changes into this. Okay, so I did nothing, I just kept M value. In place of M I kept 1 value. Okay, 1, I kept 1 and I divide it by 1. Okay, so on substituting the values of RF and T at a 25 degree Celsius, we get, so in this reduction potential also I will calculate at a 25 degrees Celsius. Okay, so in both, in oxidation potential also we have to calculate at a 25 degrees Celsius, and in reduction potential also we have to calculate for at a 25 degrees Celsius. So at a 25 degrees Celsius, E value changes into E is equal to inert reduction plus 0.0591 by N into log M power n plus reduction, and okay, this value becomes what? This value becomes equation 7. So let it be equation 7. So if we observe in equation 6 and 7, by observing in equation 6 and 7, what we can conclude? We can conclude that electrode potential value is increasing, because here positive sign, because E reduction plus before it was came minus, so plus means increasing, means negative means decreasing. So here in reduction potential means plus came na, so plus came means increasing na. Okay, so electrode potential value is increasing with increasing concentration solution. So as we increase concentration solution, then our value will increase. Then what will increase? Electrode potential value will increase. Okay, so in this way, if we increase concentration solution, then our what will increase? Our electrode potential value will increase. Okay, so since now finally I have two equation. Okay, what is that? Nernst equation for the oxidation potential value I have, and then Nernst equation for the reduction potential value also I have. Now Now finally I am going to find out the EMF of a cell. So for this I have to add both of this equation, okay? That is nothing but Nernst equation for the oxidation potential, and also I have to find out the and also I have to add the Nernst equation for the reduction potential also. So I'm going to do nothing. I will just add that both the equation, and then finally I will get this EMF of a cell equation for the Nernst equation. So in the similar way, I added here electrode potential for oxidation value and electrode potential for reduction potential. Let it be equation 8. Okay. Let it be equation 8. So what is my oxidation value, oxidation potential value is this much. Okay, oxidation potential value is this much. So I did here. Okay, E naught oxidation minus 0.0591 by n log em power n plus oxidation plus, and this is my oxidation reduction potential value. So I added here E naught reduction plus 0.0591 by n into log into em power n plus C reduction. Okay, this is I have to write down base reduction. I have to write down here base oxidation. Okay, because I'm doing for oxidation and I'm doing for reduction potential here. I am doing for reduction oxidation potential here. So I kept here in base on base oxidation, base here reduction. Okay, so I just by keeping those value here and adding this value, I got this much. Okay, so E is equal to E naught oxidation plus E naught reduction plus 0.0591 by n into log m power n plus reduction minus log m power n plus base oxidation. Okay, so adding this. Okay, adding this, why I took a common here. Okay, 0.0591 here also, and 0.0591 is here also by n. So since both is equal, so I take out this value outside, and I have taken common. This. Okay, this two value, and I bring this value outside. Okay, and then what is left? Log value is left, em power n plus reduction value is left, and then what is left? Those value I kept inside. Okay, and I have bracket open also and bracket close also. So after doing this, after finding this, what is left then? So E is equal to E naught plus 0.0591 by n into log. This is nothing. This is simplification only. Okay, you can do yourself by doing up to this much, up to equation 7, and keep equation 7, add equation 6 and equation 7. Okay, then E naught plus 0.0591 by n into log m power n plus reduction by m power n plus oxidation. Okay, from where I wrote, see in above equation 8, you can see here the E reduction value plus E oxidation is equal to this much. So directly I wrote that value here, and finally I can write down EMF of a cell E is equal to EMF of cell E is equal to E naught plus 0.0591 by n into log m power n plus for reduction potential by E power n plus by oxidation potential. Okay, in this way we can calculate. Okay, in this way we can calculate for Nernst equation. Okay, this is the method, this is the process. So this is the method, this is the process by which we can calculate the Nernst equation for the oxidation potential, and also we can calculate for the Nernst equation for the reduction potential. So if you like my video, then please don't forget to like and subscribe, and don't forget to click on bell icon also. If you click on bell icon, then you will get notification. Okay, so that you can see me in next video also. So thanks for watching video again. See you in next video. Till then, tata, bye bye, see you again.